Hi, everyone, and welcome to today's session. We are going to be covering the topic of how to create your own pop-up GPU inference server with LLMWare. You might ask, what is a pop-up GPU server and why do I need one? Well, what we found is that it's a very common development pattern in building an LLM-based application, especially for something like retrieval augmented generation. And what you need to do is to be able to rapidly integrate a self-hosted model into a RAG workflow. And what we want to do is we want to make it as easy to make a custom open source model integrated into a workflow like that as a proprietary API-based model. So you can rapidly compare and evaluate different models to see which model is going to be best fit for purpose for a specific use case, to be able to do the whole thing in private cloud, and to be able to dynamically bring it up and bring it down without getting locked into a whole set of dependencies or a particular platform. So what we're going to show today is actually a very simple, but we believe a very common use case pattern. First, we're going to fire up a GPU-based cloud instance. In this case, we're going to use AWS, but you could use Paperspace, you could use Lambda Labs, you could use Google, Microsoft, wherever you happen to have availability of a GPU-based instance to create. On that instance, in a few minutes, we're going to set up an inference server. We're going to use a Dragon RAG fine-tuned llama model, a 7 billion parameter model. We're going to get it up and running in a few minutes with a few lines of code. And then we're immediately going to flip over back to our laptops, back to the client application, where we're going to be able to call that GPU and integrate it into our workflow seamlessly. Now, the tools that we're going to use LLMWare. You can either pip install or pull from our repo to get the latest. We're going to use a Dragon 7 billion parameter llama model. You can see all the details about that in our repo on Hugging Face. And then you can use any GPU that you want. The key specs, it should be an NVIDIA A10, A5000, A6000, of course, an A100. At least 20 gigabytes of RAM to do a generation comfortably for a 7 billion parameter model. We find 24 gigabyte instance with an A10 is actually a very good setup if you're going to be doing only one generation at a time. So if you're not batching up inferences. We're going to use, in this case, just an AWS G5 2X large. The current on-demand spot price for Linux Ubuntu, which is what we're running on, is $1.21 an hour. Now, depending on the GPU that you deploy, there might be other dependencies that you have to install. In this case, all we have to do is install LLMWare and Flask, which is the web application server that we're going to be using. So the demo scenario, we're going to start the instance on AWS. We're going to launch the inference server, and then we're going to show you how to start using that client code on our laptops. And stay tuned, because in follow-up videos, we're actually going to do all kinds of cool things once we actually have this inference server set up. Now, one last proviso. This is not intended to be a production-grade inference server. There's a whole set of machinery that you're going to want to build out so that you can serve multiple clients concurrently, bringing in state-of-the-art techniques like dynamic batching. You're probably going to need a much larger GPU memory, and you're certainly going to need a more robust application server on top of this. So this is not for production grade. It's for fast, rapid development, test, and prototyping. So with that, let's flip over, take a look at the demo. And as I said, we are just using AWS. This is the instance that we fired up. This is the IP address, and it was just a pop-up IP address. It isn't an elastic IP or anything like that. We just went ahead and we fired up this instance. Now, on this instance, we've actually cloned from the LLMWare repo. We've gone into that repo, and so this is running on our instance. You can see all the examples, and it's something that we would really encourage you to do. The key example that we're going to be running here is this launch LLMWare inference server. This is going to take care of running the server for us. It is going to take a minute or two to run, so we're going to go ahead and start that, and then I'll explain a little bit about the script. Now, the first time that you do this, you're actually going to see the model being pulled down from our Hugging Face repo. We've already done that, so it'll go a little bit faster. Pulling down 13, 14 gigabytes can take a few minutes. even loading that into memory as we're firing up the inference server can take a minute or two itself. So while this is loading, what we're actually going to do, we're going to flip over to just another console window. And we're just going to take a quick look at what's in this inference server script that we've just created. Here, we'll set these up side by side. So there's a lot of comments on this about what type of server you need, some of the dependencies depending on that GPU server, a list of all of the models that the server has been designed to work with out of the box. In this case, as I mentioned, we're going to be pulling the LLMWare Dragon Llama 7 billion parameter model. But you can easily, just by changing that configuration or adding it on the command line, you can pull down another model into it. And then really the one line that's doing all the work here for us is out of the LLMWare library, and it's creating this LLMWare inference server, pulling down the selected model. In this case, it's just coming from a standard model catalog, but we have the ability to adapt and create our own model catalog. We set up a secret API key, in this case, demo test. We're actually going to be using that on the client side then when we call into the server. In this case, we set up the home path. It's just a standard Ubuntu server, so it's home Ubuntu. And then we're just going to start the server. Now, what we're going to need when we go over to the client side is really two things from this. The first is we're going to need the URL and the port, and then we're going to need that secret API key that we've set up. Those are the only parameters that we're going to need to take from the server to bring back into the client code so that the client code knows how to recognize this server. So this is just taking another second. While this is loading up, what I would encourage everybody to do is check out all these examples. We're adding to them every week. What we want to keep bringing into LLMWare are best practice recipes, really innovative ways to build LLM-based applications. So a few of the examples that we've just added are everything from parsing PDFs at scale and extracting PDF tables from financial statements and documents, building scalable embedding spaces using Milvus, a whole variety of really interesting RAG scenarios with contracts, with invoices, with other structured documents. So while we wait for this, we would really encourage you go into the LLMWare repo, and we'll just take a second just to do that. You can see we're in our GitHub repo. Here's the latest list of all of the examples. We're using this script right here, the server script. You can pull it down and copy it. And then what we're going to jump over to is the client script. And the client script, as you can see, is really simple. This will be running locally. I'll actually have it on my laptop. And what we're going to do is very simply, we're going to set up our custom LLMWare server. And all we need to do, as I mentioned, is pass in the URI string, pass in our secret key, and then that inference server gets registered as a model in the model catalog. And then to invoke it, all we have to do is use this special reserved word, the LLMWare inference server. And then immediately it can be pulled into a prompt. And we're going to show two different ways then that you can start to use it. One is embedded in a prompt where you can start using prompt with sources. You get all the benefit of all the fact checking. Or if you just want to make a direct call, all you need to do then is call the model name as the LLMWare inference server. All right, now let's see. All right, we are up and running. So what you will see is we loaded the model. You can see now that Flask is ready and is serving. And what we're going to do then is we're actually going to flip over just to my laptop code. This is the sample script that I just showed you in our GitHub repo. And all we're going to do, as I mentioned, is this one key line sets up the custom inference server. We've set up a very simple query and context just to test it. And then two different ways to invoke it. As I mentioned, you can pull that inference server directly into a prompt, or you can call it directly as a model. Now, when you run this, the only thing you're going to have to change is update this IP address. Update this IP address to the GPU server that you just created. Make sure that the secret key matches the secret key that you added, and then we are ready to go. And we've just run, so that's success. We ran 2 inferences. What you can actually see then, this is on our GPU server. It received the input and ran it twice. So once in the context of a prompt, the other in the context of a model. And now you can see kind of behind the curtain, it's receiving that input, it's yielding the output. You can see the processing time, and you can see actually how fast and how easy that inference is. So stay tuned. As I mentioned, this is just video 1. What we're actually going to do in the next video, now that we've got this inference server set up, we're actually going to deploy it then in a RAG scenario, all on local development. And our local development then is going to be using the inference server that we just set up. So thank you for joining today, and stay tuned for the next video. Thank you.